Hi, in this tutorial we are going to solve a question related to radical halogenation reactions. So the question asks us, draw the products formed in each reaction and include the stereochemistry around any stereogenic centers. Let's start from the first option. In the first option, we have an alkane, chlorine molecule, and light. So this will be a radical chlorination reaction, and let's include the products formed in this reaction. Before starting, let's mark the different types of positions in the alkane molecule. So here we have a primary carbon having three hydrogens that possibly abstracted by chlorine radical. And here we have a tertiary carbon, and since it's a symmetric molecule, we have here two secondary carbons, and then we have another secondary carbon at the end of the molecule. So basically the hydrogens in these positions can be substituted with chlorine. So let's draw the possible products. The first one, let's place on a position A. And this molecule does not have any stereogenic center, so we don't have to include stereochemistry. The second molecule at position B, and if you look at here, this carbon is a chiral carbon, so we have to include here a stereo product. We know that this reaction proceeds through this radical intermediate, and we know that the radical centers are sp2 hybridized and planar, so addition of chlorine can happen from both faces, up or down faces. For that reason we can have both stereoisomer. So in this case I'm going to put a parenthesis. This product will be formed, but I will show you this. I will show the stereochemistry around this chiral carbon. So the methyl group I'm going to choose as wedge representation and chlorine as dash representation, and the other stereoisomer, these are basically enantiomers of each other. So this will be chlorine and this will be methyl. And let's move to the third one. When we have substitution at C position, let me include here. So the product will be, so methyl will be here, and we will have here chlorine. And if you analyze again here, this carbon is a chiral, it is a stereogenic center. So again, we have to draw the stereoisomers that are forming. So I will again draw with dash and wedge representation. I'm choosing, there's a hidden hydrogen here. So in skeletal structures, as you know, we don't write the hydrogens, but I'm going to include it here. So chlorine, I'm choosing to be as wedge, and the other stereoisomer, just include the same representation, but replace chlorine with hydrogen. So again, these are enantiomers of each other. And the fourth one at the position D, I'm going to, let's say that this is A, this is B. B has like two stereoisomers, and these are C's, and D here, let me draw it here. the here chlorine, here methyl. And if you analyze the molecule carefully, we don't have any stereogenic center because this is a highly symmetric molecule, so we don't have any chiral center. Okay, let's move to the second option. Okay, let's just separate the answer from other option. In the second option, we have bromination, and uh, as opposed to chlorination, bromination is a very selective halogenation. If you have tertiary positions, the bromination will be exclusively at tertiary positions rather than secondary or primary position. And here we can see that this is a tertiary carbon, and bromination will be occurring at this position exclusively. So let's draw the product. So again, we will have two isomers, two stereoisomers. Like, let's choose methyl as wedge, and bromine will be represented with dash, and the other stereoisomer. Again, this is a radical reaction. The radical intermediate will be again an sp2 hybridized planar molecule. So we will have both isomer forming. So I'm going to just replace bromine with methyl. Okay, we have one product with two stereoisomers. So these are again enantiomers of each other. Okay, let's move to option D. Option D is again bromination. Check for any tertiary position. Yes, here we have a tertiary position, and bromination will be particularly at this position, and you can draw the molecule having the bromination at this tertiary carbon. Again, just choose methyl group as wedge. In the first case, bromine that is attached, you can choose as a wedge representation, and vice versa. Again, you can choose in this case bromine as a wedge and methyl as dash. Okay, let's move to the last option. Last option is radical chlorination, and we have to check again like stereogenic center. So here we don't have any hydrogen, so there will be no chlorination at this position. Here we have a secondary carbon, and we have here a hydrogen, and we have here another secondary carbon, and we have two hydrogens, and we have a primary carbon here having three hydrogens. So, and possible hydrogen, like the sites of hydrogens will be a possible chlorination reaction. So let's start from the primary one, so from this end, and again I'm going to label this one as A, this one as B, this one is C. So let's start from the A, from the left side. Okay, if we have chlorine here, since there was a fluorine here, and there was 3 chlorine in this side. So here, this is not a stereogenic chlorine, so we don't have to write any stereoisomer for this case. Let's move to second carbon, which is at position B. So, okay, let's write the fluorine as dash here. We have 3 chlorine here, and we will have chlorine here. If you check this position, this is a chiral center, so we have to include here stereochemistry. So we can like choose this chlorine to be as wedge, and there's a hydrogen here. You can choose to be as dash, and vice versa the other stereo isomer. I'm not going to draw it, but this one plus the other stereoisomer, basically the enantiomer. So, and in the last case for the C, again we can write here this 3 chlorine. There was a fluorine here, dash, and the chlorine will be wedge. And again, since the radical intermediate, it's going to be planar, so the other stereoisomer, basically you just flip fluorine with chlorine position, and basically we will have 2 stereoisomers from here, 2 stereoisomers from here. We don't have any stereoisomer from here because the chlorine substituted chlorine's carbon is achiral. Thank you so much for watching the video.